Hi students, today's topic is about periodic table, periodic properties and variations of properties. That is the first chapter of your chemistry syllabus of class 10. So in this video I will share my short notes that I have prepared from your books and that will help you a lot. So all questions you will just get answer from a single short note. So let's get started. So my request to you is just listen to me carefully, so that it can help you. The short note can help you while memorizing the facts and figures. So let's get started. So modern periodic table just come after a long research, and the research has been introduced by Mendeleev. He gave the first periodic table of elements based on his law, which says that the properties of elements are the periodic functions of their atomic masses. But later, Henry Moseley put forward a new principle, and he says that the physical and chemical properties of elements are the periodic functions of their atomic number. So this is this is something the most acceptable theory. So we are going to read about this periodic table. So the first thing that I want to tell you, periodic table consist of 18 vertical columns that are called groups. And here the number of electrons present in outermost shell is same. For example, this is a periodic table. So this is hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. One thing must we say that you have to remember some of the periodic table elements. I will suggest you to remember from 1 to 20 atomic number of elements. So for example, 1 goes to hydrogen, 2 goes for helium. There is no short trick for it. So what I am going to say, that hydrogen has 1 electron in its outermost shell, while lithium has atomic number 3. It means 2, 1. That means that it has 1 electron in its outermost shell, while sodium having atomic number 11, 281, and it has similarly 1 electron to its outermost shell. So if we go down a group, we'll find this they have same atomic number, same number of electrons in its outermost shell. So that is about group. So what is period? Period is the the horizontal rows that are in a periodic table. So from periodic tables is where the number of shells are seen. For example, you can say this is a lithium. So lithium has 2, 1. It has 2 shells, while beryllium 2, 2. It has again 2 shells. Boron has 2, 5 electronic configuration. 2, 3 electronic configuration. Again it has 2 outermost 2 shell, and similarly fluorine that has electronic configuration of 2, 7. It has 2 shell. So along a period, all elements have the same number of shells. So let's move on to let's learn what groups are called what. Okay, so for example, group 1, we will tell it as alkali metals. They all are metals. Okay, I will give you why they are metals, why the elements at the left side of periodic table is non-metals. I will explain you everything, just hold on. Okay, so group 1 is alkali metals. Group 2 is alkaline earth metals. You see, alkaline earth metals. Group 3 to 12 is transition elements. They are called transition elements because they are between the metals and non-metals. But though they are metals in the properties, but they are actually between metals to non-metals. We will see this. So group 13 is your boron family. Here you can see this is the boron, aluminium, gallium, indium, thallium. So then come group 14, this is the carbon family. This is the carbon family. Group 15, it is called nitrogen, as first element of this group is nitrogen. We can also call this group as nitrogen. Then come your oxygen family. We can also say it chalcogen, and this group where they are the most electronegative. Okay, first let's understand this part only. So okay, when this group 17, where exist fluorine, chlorine, bromine, iodine, astatine, so this group is called as halogen. Okay, and this I also forget to tell, this is the most interesting group, that's group 18. It is called as inert gas group or noble gas. So that is all about. So next move on to our next definition, that is periodicity. Periodicity is the properties that reappear at regular intervals. I previously told you that if we going down a group, we will see that each elements of each elements having same number of electrons at its outermost shell. And while we want to define chemical properties of a compound, the outer electrons in the outermost shell play the most important parts. So that is why this is very important while defining chemical properties of any compound. That is why this type of property helps to hold a similar chemical properties to these elements. So this is the property that it periods, because the properties that reappear at regular intervals, you can see the first after hydrogen there comes lithium, and between hydrogen and helium the difference is 2, because it is 1 and 3 and it is 2, between difference is 2. Then lithium to sodium difference is 8, sodium to potassium difference is 8. So that means that after from sodium, if we just read 8 elements, will came to potassium that has a similar property like sodium. And then rubidium, it has after it comes after potassium just after 18 elements, then cesium after 18 elements, and then francium after 36 elements. Okay, so that is about periodicity. Let's move on to valency. Valency is the number of electrons an atom can donate or accept or share. There is the element sodium. Sodium has electronic configuration 281. That means it will donate 1 electrons. This 2,8 will find, if we just think about electronic configuration 2,8, we will find the same electronic configuration for neon. Neon, that is an inert gas. This is an neon gas. You know why the inert gas? Why these elements of the 18 groups are called inert gas? Because their electronic configuration is so stable that they cannot want to react with other elements. Reactivity is something that if we are in a, or the atoms are in an unstable condition, they want to react with other atoms just to get a stability. Similarly, here the electronic configuration for all these group 18 elements is in a stable condition. Okay, that is because they has the fulfilled outermost shell. So this is a fulfilled, because it cannot accept, the outermost shell of those elements cannot accept or donate an electron. So if the stability will get vanished. So every atom want to get, they has a tendency to get electronic configuration like them. So that is why they react. Similarly, if sodium just donates 1 electron, it will get the electronic configuration like neon. That is why it will get a stability. That is why it is donating 1 electron only. Similarly, aluminium, if it donates 3 electrons, it will be like neon, and that is why it gets stability. For this reason, aluminium donate 3 electrons. So this is the property of a element, that the number of electrons an atom can donate or accept or share is called this valency. So if you are asked that what is the valency of sodium or aluminum or any other kind of elements, then you will say that sodium has valency 1 or aluminum has valency 3. Okay, let's move on to periodic properties. So previously I told you that in a periodic table, if we going down a group, there is a similarity in chemical properties among the group elements. So why this is so happening? What is the periodic properties? What periodic table wants to say us? So let's start with atomic size. Periodic properties first depend on atomic size. Atomic size is called the distance between the nucleus and the outermost shell. Let's for example, this is your sodium, and sodium has 3 shell. First shell has 2 electrons, second has 8 electrons, and the third has the 1 electrons. So in this case, the distance between the this is the center of the nucleus of sodium to the outermost shell, this one where it holds only 1 electron, is called its atomic size. So atomic size depends on definitely on number of shells, because if we rise the number of shell, for example, we move from sodium to potassium, we will see the electronic configuration of 2, 8, 8 and then 1. So it has one shell more than sodium. That is why it has more atomic size. Its atomic size is bigger than sodium. Okay, it also depends on nuclear charge. As we increase nuclear charge, the atomic size will also reduce. Sorry, I have done a mistake. It is disproportional to. If we increase the nuclear charge, the atomic size will get reduced. For example, going left to right of a period, sodium, magnesium, aluminium, silicon, potassium, sulfur, chlorine, whatever. So we will see that the period has same number of all the elements of these periods have same number of shells. So just they are getting 1 electron more from each. That's from sodium 11, magnesium 12. It means it has 1 electron more than sodium. So if we go from sodium to chlorine, we'll see that each element has the same number of shell. Just write down the electronic configuration of sodium to chlorine. So you will find this. So here we are just the effective nuclear charge is increasing. Okay, so for example, there is sodium that has 2 shell, while there is chlorine that has a nuclear charge of 17 neutron plus protons, and it has the same number of shell. Definitely, sorry, I'm just repeating it. So for example, there is sodium. If it has 2 shell and it has 11 protons, and chlorine has 17 protons, so definitely it will attract the electrons of its outermost shell more strongly, because it has more protons or more nuclear charge. That is why atomic size is disproportional to nuclear charge. So if we increase the nuclear charge, the atomic size will get reduced. So we can also conclude that along groups, if we move from top to bottom, then as the number of shell increases, atomic size increases. Similarly, if we go left to right from along a period, number of shell are same, but the nuclear charge is increasing. That is why atomic size is decreasing. So inert gas, they face actually electronic repulsion in their outermost shell, but actually they are stable. Okay, so now I have told you previously that I will tell you everything about metal and non-metals. So what is metallic character and non-metallic character? Metallic character is for which metal has tendency to lose electrons of outermost shell or valence shell. So valence shell is that is our outermost shell. For example, sodium has 1 electron in its valence shell, and if it's just donates electron, because it will have to get electronic configuration like inert gas. So it will become sodium plus. So this is a kind of oxidation. Oxidation because sodium donates an electron, and that is why its oxidation state is here +1. Valency is 1, but oxidation state is +1. So if oxidation state goes from 0 to +1, it is called as oxidation. And as this sodium is releasing an electron, donating an electron to some other atom, so this is called as reducing agent, because when this sodium donates its electron to another atom, it oxidation state get reduced. That is how it reduces its oxidation state. That is why sodium is a reducing agent here. One thing I have forgot to tell you, that anion has greater atomic size than its parent atom, while cation has lesser atomic size than its parent atom. Let's have an example of chlorine and Cl-. So when chlorine becomes Cl-, it gets 1 electron to its outermost shell, but its nucleus has still 17 protons. That is how its effective nuclear charge gets reduced, and chlorine minus get more new atomic size than chlorine. While there is an example of sodium, when sodium donates 1 electron from its outermost shell, it becomes Na+. But sodium, nucleus of sodium has 11 protons already. That is how the effective nuclear charge of sodium get increased, and thus sodium plus get less atomic size than sodium, its parent atom. That is why I have written here that anion has greater atomic size than parent atom, and cation has lesser atomic size than its parent atom. So I have told you about the metallic character, so for which metals has tendency to lose electrons of its outermost shell. So metallic character also depends on the atomic size and its nuclear charge. So if we raise the atomic size, the nuclear pull in valence shell will decrease. That is how the tendency of donating an electron pair will also increase. That is why we can say that if we increase the metallic atomic size, metallic character will also increase. That's why going down a group, as there is the increase of atomic size, increase in number of shell, and increase in atomic size. That is why if we go down a group, the metallic character of elements, okay, similarly it has a disproportional relationship with nuclear charge. So because if we increase nuclear charge, nuclear pull in valence shell just get increased. For example, if we move left to right of in period, we will see that there is the same number of shell, but the effective nuclear charge is increasing from sodium to chlorine. That is why the outermost electronic shell of sodium face more electronic pull than sodium. Outermost electronic shell of chlorine face more electronic pull than sodium. That is why its metallic character get reduced, and chlorine become non-metallic element. Okay, so this is about metallic character. So then just the opposite of metallic character is non-metallic character. So for which elements have tendency to gain electron in its valence orbitals. For example, chlorine, if it gets 1 electron, it will have an electronic configuration like argon, because this is an electronic configuration of 2, 8, 7. If it gets 1 electron, it will have 2, 8, 8 electronic configuration, and thus it gets an electronic configuration just like argon, that is an inert gas group 18 element. That is why always chlorine gains electron. So this is a reduction, what I said because previously, because here chlorine has oxidation state 0, and when it reduced and get 1 electron, its oxidation state become -1. That is why it's oxidized and oxidation number get reduced, and this is called reduction. As it is donating an electron, that is why it is an oxidizing agent. That is why chlorine gas always react just like an oxidizing agent. Okay, so chemical reactivity is something that when metals, the tendency of metals to lose electrons increases. We will see that the chemical reactivity of metals is increasing when non-metallic compound are gaining electrons and it is increasing. Then we will say that it is chemical reactivity. Okay. So that is all about the chemical reactivity of metals and non-metals, because metals has a tendency to lose electrons, while non-metals has always tendency gain electron. So metals, if in loss more electrons, it will have more chemical reactivity. Then the tendency of non-metals to gain electrons increase, it will have more chemical reactivity. So for period, firstly, tendency to lose electron reduced, because we are having the same number of shell, but the effective nuclear charge increase. But that is why the reactivity of metals decrease. But after that, we found that the tendency to lose electron increase, because here the outermost shell is getting bigger, and that is why its reactivity also increase. So that is why I can say that from sodium to aluminium, the reactivity of metals get reduced, but while reactivity of non-metals increasing, because from phosphorus to chlorine, non-metals they want to accept electron, so that is why their reactivity also increase. Okay, I have done some mistakes while preparing the short notes, and I'm going to correct this on my way of teaching, so definitely I think that you will handle it. So this is about group from lithium to cesium. As the atomic size is increasing, the electrons in the outermost shell of an element face less nuclear pull, and that is why their tendency to lose electron increase. That is why metal character increase, and chemical reactivity also increase. And fluorine, chlorine, bromine, iodine, as their tendency to lose electron increase. That is why their tendency to lose electron decreases. Their tendency to gain electron increases. That is why we'll see that the non-metallic character decreases, because from, if we go down from fluorine to iodine, we'll see that their atomic size is increased, and then the outermost shell of iodine is facing less nuclear pull than fluorine. That is why its non-metallic character get reduced. Okay, let's move on to ionization potential, and for metals and non-metals we will learn more just shortly. So ionization potential is the energy required to remove an electron from an isolated gaseous atom. Remember, this term is very important. Isolated gaseous atom. Only when an electron will remove from an isolated gaseous atom, then the amount of energy released, only this energy we will consider as ionization potential, ionization energy, or ionization enthalpy. So its units, it's electron volts per atom and kilojoule per mole in SI. Okay, so at ionization enthalpy also depends on two factors. Here is atomic size and then this nuclear charge. So if we increase the atomic size, the outermost shell of an element will face less nuclear pull, and that is why energy to remove an electron from its outermost shell will definitely need a lesser energy. That is why its ionization enthalpy will reduced. When again nuclear charge increased with ionization potential, because if we increase nuclear charge, for example going along a period from left to right, we'll find that then effective nuclear charge is increasing if we move from lithium to fluorine. So in that case, as the nuclear charge is increasing, the outermost shell is facing more nuclear pull of attraction. That is why it to remove an electron from the outermost shell of fluorine will need more energy. That is why its ionization potential is more than the elements that have more atomic size. Okay, I hope you understand. So whatever, okay, so that was about ionization potential. Next move on to electron affinity. Electron affinity is a little bit opposite of ionization potential. Here we consider the energy that was gained, that will be gained while to remove an to add an electron to a gaseous atom, isolated gaseous atom, and to make it an anion. Okay, I'm just repeating it. Listen very carefully, that when we want to add an electron to the outermost shell of an isolated gaseous atom to make it an anion, gaseous anion, then the energy released is called electron affinity or electron gain enthalpy. Okay, so its unit is electron volt or atom per atom or kilojoule per mole, similar just like ionization potential. It also depends on two factor, atomic size and nuclear charge, just like ionization potential. If atomic size increase, the outermost shell of an element will face less nuclear charge, and that is why to push an electron or to add an electron to its outermost shell, if we add an electron to its outermost shell, it will release more energy. Similarly, if we increase the nuclear charge, to gain electron to its to add an electron to its outermost shell will produce more energy. That is why electron affinity or electron gain enthalpy increases. So going along a period, if we move left to right, we'll found that as the atomic size is reduced, as the effective nuclear charge is increasing, so electronic enthalpy, electron gain enthalpy is rising. As going along a period, we will find that the atomic size of the elements are getting reduced, so the effective attractive force between the nucleus and the valence electrons is just get increased. That is why the electrons are held firmly, and thus the energy released is more. Always remember that if you want to add something to a element that gets gets stability just after adding an electron, it will release more electron affinity, electron gain enthalpy. So similarly, if we going down a group from top to bottom, electronic enthalpy also electronic affinity also decreases, because going along a group, atomic size increases and nuclear pull of attraction towards the outermost shell of an electron will reduce, and thus electrons on the outermost shell will hold not firmly, weakly. So that is why electron affinity will also reduce. Okay, so this is all about electron affinity. I hope you understand, but even if you have any kind of doubt, you may ask me in the comment section or just mail me. So I will explain you definitely. So let's move on to electron affinity. Electron affinity is the tendency of an atom to attract the shared pair of electrons towards itself. So this is this is the tendency of an atom to attract the shared pair of electrons, or shared pair of electrons, because electronegativity is mainly observed by the elements that produce on the form covalent bond, and Pauling scale measures this electronegativity. Electronegativity also depends on two factors. One is atomic size and nuclear charge. Definitely, if we increase atomic size, a nuclear pull of attraction will reduced at the reduced at the outermost shell of that element, and the tendency to share an atom to attract a shared pair of electrons towards itself will definitely get reduced. Okay, so if we again increase the nuclear charge, a nuclear pull of attraction will create at the outermost shell of an electron element, and thus to attract a shared pair of electrons will increase because it has more nuclear charge, more effective nuclear charge, more nuclear pull of attraction. That is why definitely it will have a tendency to attract the shared pair of electron towards itself. So that is all about. So along a period, if we go from left to right, we'll found the electronegativity is increasing, because at the same case the atomic size is reducing, and effective nuclear charge to the outermost shell of an electron will increase, and thus the electronegativity, or the tendency of that atom to attract the shared pair of electrons towards itself will increase, and thus electronegativity will increase. Similarly, if we move down a group, electronegativity decrease, because here the atomic size is increasing, electronic pull of attraction to the outermost shell of an element is decreasing, and thus tendency of those atoms to attract the shared pair of electrons towards itself is reducing, and electronegativity thus reducing. So finally, I can say you something, or just conclude you that when we increase atomic size, or when the atomic size get increased, effective nuclear charge to the outermost shell of any element get reduced, metallic character increase because tendency to lose one electron from its outermost shell is increasing, and non-metallic character reduce because tendency to accept an electron to its outermost shell is reducing. Chemical reactivity of metal increasing, because as the metallic character is increasing, ionization enthalpy is decreasing, because this element will now require less energy to remove the electron from its outermost shell. That is why its ionization enthalpy will reduce. Electron affinity will also reduce, because as the elements have less or a nuclear pull towards its outermost shell, so electrons in the outermost shell are not held firmly. That is why its electron affinity will also decrease. Electronegativity also decrease, because the nuclear pull, effective nuclear charge to the outermost shell is reducing. Similarly, melting point of metals is also increasing, because the force of attraction between the atoms is decreasing, and for the same reason boiling point of metal is also decreased. In metals, the metallic bonds are formed in this way. So when the metals are closely packed, the atoms of metal is closely packed, metal atom lose electrons from their outermost shell, and thus metallic bonds involve strong electrostatic forces of attraction between the metal centers and the electrons, and this force holds the atoms of metals together. Actually, here the metal centers are suspended in the sea of electron. So when the atomic size of an atom increase going down a group, melting point of metal reduce, because as the metallic atoms then become greater in size than before, and thus there become the force between the atoms, it reduce because of their size. That is why the melting point of those metals going down a group will reduce, as due to their size their force of attraction will get reduced, and thus the melting point, that means that the energy required, the heat required to melt them will be reduced. Okay, similarly the boiling point of metal will also reduce, but the opposite things it happens for non-metal bonds, because in non-metal bonds they preferably bond in a covalent manner. So for example, chlorine, it has of electronic configuration 287. So if both two chlorine atoms share a pair of electron between them, they both get just electronic configuration just like an inert gas, argon, and thus get stability. So there is no transfer of electrons, and both share. There is only sharing of electron. So effective nuclear charge to the outermost shell decrease as atomic size increase, and thus the non-metallic character increases. As we move going down a group, we'll found that as the non-metallic character increase, tendency to lose electron also increase, and there will be a strong covalent bond, and more energy will required to break the covalent bond. That is why more energy is required to melt them. So going down a group, the melting point of non-metals will increase, but melting point of metals will increase because of their atomic size. As it is increasing, the force of attraction between the atoms will increase. That is why their melting point will also increase. So did that atomic size increasing, effective nuclear charge to the outermost shell decreasing, metallic character, that the tendency to lose electron increased, non-metallic character reduced, chemical reactivity of metal increasing, ionization, enthalpy reduced. I explained you earlier, electronic enthalpy is reducing, electronegativity reduced, melting point of metals reduced as the force of attraction between the atoms reduced, and boiling point of metals also reduced. But there is another kind of thing happens for period. For if we move from left to right, the melting point first increase for metals because of the delocalization of electron. If we move from left to right, for example sodium, magnesium, aluminium will lose more electron than sodium. It will lose 3 electrons. That is how in this case electrons will rise in this case, and there will be a strong electrostatic force of attraction between the atoms of those metals. That is why along the period from left to right, due to metals and the metallic bonds, this electrostatic force of attraction get increased and melting point increase. But it then decrease, because we know that most of the non-metallic compounds reside at the right of the periodic table, and then come the non-metallic compound which have less atomic size than the metals, and that is why the covalent bond become weaker, because in this case the tendency to lose electron is the least. That is why there is no strong covalent bond, and thus the melting point is reduced, as the energy required to break the bond is very less. So I hope you understand all the facts what I going to say you in this whole part. So in the next video I will discuss some questions on periodic tables. So definitely this topic become more clear to you. But before that, I hope you understand all the things. If you have any doubt, you can ask me in the comment section or mail me. I have given my mail account to the description box. Please check it. If you want short notes that I have made to teach you, you can just mail me. I will send you the PDF of those short notes. So okay, thank you for watching. If you have any doubt, please comment, and don't forget to like, share and subscribe. Thank you for watching.